Chapter H, a quotient rule. In this case, we would like to take our function f of x to be a quotient, a u of x divided by a v of x. Now, I prefer not to think quotient, but product, because see, I can write this as u of x times v of x to the minus 1 power. And then I know the product rule, so I'm going to apply the product rule here. So the product rule would be, let's write down df dx, and let's write this as d dx of u v to the minus 1. There's your u and v to the minus 1. So I'm going to write this as, the way I like to remember the product rule is I take the derivative of the first, du dx, times the second, which is v to the minus 1, and then take the first times the derivative of the second. And now I'm going to use my chain rule. My chain rule is going to kick in here. What I'm going to do is consider the g of v, a function of v, is simply v to the minus 1. Then, to get dg dx, which is what I'm after, say I want the derivative of v to the minus 1 with respect to x, I would use the chain rule. I would take the derivative of g first with respect to v, and then the derivative of v with respect to x. That's our chain rule. So the derivative of g with respect to v, that would be equal to, you bring the minus 1 down, and you'd have v to the minus 2. That would be this first term here. But then I need to multiply by dv dx. So we'll just simply put down dv dx second, like that. So here, this term here, the second term here is simply dg, because the g is v to the minus 1, dx, that second part there. And then I simply use the chain rule. So what do we have? We have df dx is equal to, up here I have a du dx with the 1 over v. So that's going to be du dx with the 1 over v. But then I have to add something to that. And what I'm adding to that is u times what I have here. Because this is simply dg dx, this second factor. Just have to put a u in front. And there's a minus sign, so I have minus u. And now I have 1 over v squared, so I'll do this. And then I have dv dx, I'm finished. Now let's write this in summary as d dx u over v. And that's going to be here u prime over v minus u over v squared v prime. Now I would like to find a common denominator here. So here I would have d dx of u over v. If I find a common denominator, v squared, this first term here would be u prime times v, so that 1v cancels out. Then I would have a minus sign, and since I have the v squared there, I would just simply have u v prime. Now this is the quotient rule, and you can remember it this way if you like. You take the derivative of the numerator times the denominator, and then you subtract the numerator times the derivative of the denominator and divide by the denominator squared. I don't find that useful at all. In fact, I'd rather just do what I just did for you here, always set it up as a product rule, and then look, I can derive the quotient rule. So I always just use the product rule rather than memorize this. So if I use the product rule here, just to review in one step, I would have the derivative of the first, which is the u prime. All right, I would write this as d dx, u, v to the minus 1. That's how I would write this. I would get then the derivative of the first times the second, which would be here 1 over v. And then I would have the first times the derivative of the second. The derivative of the second is minus 1 over v squared v prime. And if I put the u in front, I get the result very, very quickly. I don't even bother with this form. Okay, so let's look at how we may check this with our, let's see how we can check this. I'm going to pick u is 10x cubed. That's going to be a numerator function. I'm going to pick v is 2x squared. So then I could find u over v very quickly. And that's going to be 10x cubed over 2x squared, which is going to be 5 times x. So the derivative with respect to x of u over v, I know is going to be simply 5. But now let's try that with the formula. So the formula says we need to take u prime. Well, u prime is 30x squared. All right, so let's look at this one here. This is 30x squared. And v is 2x squared. So I divide it by 2x squared like this. And then I need to subtract u, which is 10x cubed, multiplied v prime. Well, v prime would be 4x. And I would divide by v squared, which would be 4x to the fourth power. All right, so u, 10x cubed, v prime, take the derivative, you get 4x, and then v squared, 4x to the fourth. All right, let's look at this. Well, this first one here, the x squareds cancel, and you get 15. And the second one here, the x cancels again because you have x to the fourth over x to the fourth. So I have here the fourth canceling, so I simply have minus 10. And that is equal to 5, which is what I got. So let's summarize our rules of differentiation. We're going to have a summary here. And for the summary, let's do the sum first. The sum says that the derivative of u plus v, this combination, you simply take the derivative of each one and add them. And then if we look at the difference, you would have d dx of u minus v, and that would be simply u prime minus v prime. And then we have the product rule, which would be d combination uv dx, and that would be take the derivative of the first times the second, plus the first times the derivative of the second. And then we have the quotient rule, where we're taking d u over v dx. And here, the quotient rule, as given in calculus books, would be given by this formula, u prime v minus u v prime over v squared. But I'm going to give you the way I do it, which would be here, take the derivative of the first, which is u prime, times the second, which is 1 over v. And then I take the derivative of the second times the first. So that's going to be minus, the first is u, but the derivative of the second, I bring the minus 1 down, I get 1 over v squared, and then I have v prime. So this is how I remember it, or I just do it. And this is how a calculus book may show it. And remember, if you find your common denominator, v squared, you have then u prime v minus u v prime. You get what's in the calculus book. So you have two ways to consider the quotient rule. I'll see you next class.